All right, next example we have here, determine whether the following integral converges. If it does, determine its value. So, same idea, getting a little repetitive, but we replace the infinity or infinities, as is the case here, with a parameter, let's say r. So that's our little workaround. And now that we have this integral, it's a definite integral. Sure, there's a limit in front, but we know how to handle this way more than something like this. Okay, so we can evaluate this limit, or excuse me, this integral, which would be 1 over pi sine of pi x between negative r and r. So, looks like we have over pi, and this would be sine of pi r minus the sine of negative pi r. Quick comment about sine. Sine is an odd function, so that means sine of negative something is just equal to negative sine of that something without the negative. So this essentially means that we can factor negative signs out from the argument of sine, or thinking about it from the other direction, if we've got a negative sign, we can pull it into the argument. So in this case, whether we pull this negative out or we bring this negative in, we essentially get rid of all the negatives. So however you want to think about that, that is going to be the case. So because sine of x is an odd function, we have this nice property. So this becomes 2 sine of pi r over pi. Now if you think about what sine looks like, sure, sine of pi r times 2 over pi, regardless of that little stretch and change in frequency, sine still has this basic shape. Sure, the frequency is different. It's a little bit, 2 over pi is about 2/3, so it's a little bit, it's a shrunk down version of the usual sine. But that doesn't matter, because really, when you take a limit to infinity, you're really asking the function, do you have any horizontal asymptotes if we go in this direction? Well, sine does not have a horizontal asymptote. It always oscillates. So this limit here does not exist. So, does not exist. So this implies that the integral diverges.